if possible, sometimes we run short on time, but if possible, I will try to go over a free response question every week on the day before the quiz. So this week's is kind of disjointed a little bit because we're still at that place where we just can't do a full free response very well yet. So you got pieces of free responses here. So we'll do a couple pieces of this. Which ones do you guys want to do? What do you mean when you say 7? You're just throwing something out there. Okay. Yes. Yeah, that would be a 1-point question. Like, you basically get the answer or you don't. But that would just be 1 for that. Yeah. Okay, let's look at this one because these F-star ones are weird, right? They're a little crazy. So that it tells you earlier that F-star of x equals the limit as h approaches 0 of f of x plus h minus f of x minus h all over h. So what it's asking us to do is we've got to find f star whenever f of x is cosine x. Oh no, I am remembering why you're having trouble on this one now. Oh, I should have looked at this one more closely because I have forgotten that I did not teach you sum and difference formulas whenever you were in pre-calculus. So, it's okay. We can still do this problem. I'm gonna get and I might still pick it for tomorrow if the wheel of doom picks this, but I will give you sum and difference formulas, which I'm going to show you right now. If I do pick this one, because that's going to be an issue. I will. So if I do pick this one, I'll put the sum and difference formulas over to the side. So let's look at this one. But I probably didn't do that on the key because sum and difference we used to do in pre-cal, and we have quit doing that in pre-cal because it's not required. So if I do f of x plus h, for this function, that is cosine of x plus h. And if I do f of x minus h, that is cosine of x minus h, right? So this right here is f of x plus h. And this right here is f of x minus h for this problem. So we will have the limit as h approaches 0 of cosine of x plus h minus cosine of x minus h all over h. Now, if you plug in 0 right here, for your h, you get cosine x minus cosine x, which is 0, and you get a 0 on the bottom as well. So 0 over 0, so this goes nowhere. What you have to use here is something that you guys do not know, and that is the sum and difference formula for cosine, which I'm a little shaky on this. I think I remember this. I better consult my key in here in a second. Let me write it down and see, make sure, and then we'll double check to make sure I'm right. So sum and difference formula for cosine. I believe, we'll go double check here in just a second, that the cosine of A plus or minus B is, I am pretty sure this one is the cosine conga, if I remember correctly, where it's cosine, cosine, sine, sine. Don't forget to change the sign. So cosine, cosine, sine, sine. Don't forget to change the sign. So right here where you'll have an A right here, a B right here, A right here, B right here. And then where this is a positive or negative, we change it to a negative or positive. I'm going to pause here for a moment and pull up my answer key to this and make sure that what I am telling you is in fact correct, because it's been a minute since I did these. Cosine, cosine, sine, sine. Change the sign. Oh yeah. Okay. I had that one right. Oh, good job. Okay. So what that means for this, and this is going to be a long thing whenever we write this out, is we've got to use that formula for these pieces right here. So cosine x plus h is cosine, cosine, sine, sine. We put a x here and h here. We change our sign right here in the middle. It's going to be minus. And it'll be x here, h here. This stuff right here, all of this is just cosine x plus h. So we haven't even touched the second part. So what the minus you're looking at is right here, and we're going to have a set of parentheses for that. So then we have to do this piece right here, and so we do the cosine conga again. Cosine, cosine, sine, sine. Don't forget to change the sign. So where that was a minus right there, we'll now use a plus right here. Put the x, h, x, h right there. You can put them there if you want. They're not necessary because you don't have anything in front of it, but you could put them there if you want. Yeah. The second set of parentheses is necessary because you got that minus that's got to be distributed. So if we do distribute that negative right there, that makes this negative. It also makes this one right here negative. So we got this is negative and this one is negative, so I don't have to rewrite there. And that means that I have a positive cosine x cosine h and a negative cosine x cosine h. So those will cancel each other out. And now I've got the limit as h approaches 0 of, I've got a sine x sine h and another negative sine x sine h, so that's going to be negative 2 sine x sine h over h. Okay, this is going to pull out something else we've probably forgotten. Because if I plug in 0 right now, I get sine of 0 is 0 and h is 0, and I still get 0 over 0. But, does anybody see where we go from there? This right here is going to be 1. So if we split that up in limits, we got limit as h approaches 0 of negative 2 sine x times the limit as h approaches 0 of sine h over h. This stuff right here is just 1 because that's one of the special limits that we have. So we really just got the limit as h approaches 0 of negative 2 sine x, and that is just your answer because you're plugging in 0 for h, and this doesn't have an h in it anymore. So negative 2 sine x. So if you guys are unfortunate and the wheel picks this problem, I will include with this problem this formula right here, so that you have that to refer back to, because I know that you guys do not have that memorized, because we did not do it in pre-cal. That was probably definitely the best one to go over. Which other one do you guys want to look at? If we do 3A, we're not doing the others. Anybody else want to fight Lydia on that? Or you feel like 3A is still our best bet? Which one do you want? We kind of I didn't finish 3A all the way, but I kind of started it. Or did I let you guys finish it? I think I did. 2B? Do you guys know how to find a 0? Since we have looked at 3A, let's look at 2B real quick, because we have not found zeros in this class. That's a pre-cal thing. So, how do you find a 0? Or first of all, what is a 0? X-intercept. Okay, and at the x-intercept, what do we know? Y is equal to 0. So y is like your f of x here. So we're looking at 0 equals x to the third minus x over x to the third minus 4x. So, what's the only way that that can be 0? X being 0 actually will not give us 0, because if x equals 0, we'll get 0 on top, but we'll also get 0 on bottom, which is indeterminate form. So if I want, like if I'm dividing, I need the top to be 0 and the bottom to be some sort of number, right? 1 is looking promising, right? There's another one that'll work too. All right, so here's what I want you to look for these. The only way that you can find a 0 is for the top of the fraction to be 0. And for the top to be 0 and the bottom not to be 0, right? So what we're looking for is 0 is going to be x cubed minus x, but we also have to have x cubed minus 4x cannot equal 0. Because if we got top and bottom being 0 at the same time, then that does not equal 0. So how do I solve that if I've got 0 equals x to the third minus x?
You add the x.
If I do, I'm going to lose an answer. Now, I'm actually going to lose the answer that doesn't work anyway, so you might get away with it, but if you move the x's over to the other side and do like some dividing, you're going to lose an answer. Yes, there are 3. And it is acceptable, like you were guessing and checking. You said 0, then you said 1. There's also another one that we haven't found yet. It is okay to guess and check if you get stuck on something. But mathematically, the best way to do this, and sometimes you get ones that are hard to guess and check, factor out of x, because those both have x's, right? You're factoring x squared minus 1. And then you can either factor this one further, or you can or you can set each one equal to 0. It really doesn't matter here. I'm going to go ahead and factor that and make it x minus 1, x plus 1. So you get x equals 0, x equals 1, and x equals negative 1. Now, if you didn't show work and you just got those answers because you guessed and checked, that's okay. But we must also remember that x cannot equal 0. So if we do the same thing over here, x times x squared minus 4 cannot equal 0, which means x times x plus 2, x minus 2 cannot equal 0. So x cannot equal 0, x cannot equal negative 2, and x cannot equal positive 2. So what we've got going on here, these 2's don't really matter so much, but I've got that x cannot equal 0 and the x equals 0 here, so we're going to throw that one out, and we're going to say that f has zeros at x equals 1 and x equals negative 1. There were 3. There were 3 answers to this problem, but one of them got tossed out because the bottom was also 0. So if you are looking for zeros of a function, numerator is equal to 0, denominator is not equal to 0. And sometimes the denominator really doesn't even matter because it's not the same number. So like if we had got x cannot equal 3, x cannot equal 2, and x cannot equal 7, we would just have 0, 1, and negative 1. But in this case, because one of our numbers that we got as an answer couldn't be the answer, we had to throw that out.
Did you also come to the conclusion that you could use 0 because it would be determinate form?
Yes, that's fine. Yeah. Yeah. Yeah, so like there's options on how you show your work for this or how you explain it. That'd be fine. You could, another thing you could do instead of thinking about the denominator like I did here, you could just test all of your answers. So like if I plug in 1 or negative 1, I get 0 over a number. But when I plug in 0, I get 0 over 0. So that's another way you could check for this. So there's lots of options on how you do that. But general idea. All right, let's try answer for number 1. You would get a point for getting the limit right and a point for your explanation. Any questions on that? Anybody have like worded it differently? Want to know if theirs is okay? Then for part B, this is a continuity problem. So your points on this is a 3-point problem. You get a limit from the left as a point, limit from the right at 8 as a point, and then your answer with justification. So if you plug in, if you're doing the limit as t approaches 8 from the left of n of t, and you got to use that notation, you would use 25t plus 150. You're going to plug in 8. You will get 350 for that. From the right, you are going to plug in 8 to the bottom equation. Now on this one, you do end up, you're going to have to do a little dividing of some decimals here because, so you've got 200 plus 80 times 8 over 2 plus 0.05 times 8. You do actually have to simplify this because you got to know that it's equal to whether it's equal to 350 or not. Because if it's not, then this is not continuous. Because it doesn't say prove that it's continuous. It asks the question, is it? It might not be. So, here 8 times 8 is 64. So we got 200 plus 640. Here we got 2 plus 5 times 8 is 40, but we got the decimal, so it's 0.4. So we're looking at 840 divided by 2.4. Let's do some long division. Right here, I got 840. What do you do when you divide decimals? Move that decimal to the right one, which means you also have to move this decimal to the right one. So you're going to put an extra 0 right there. So 24 goes into 84 3 times. 12, 72. We will subtract. We will get 12. We'll bring down a 0. 24 goes into 120. 5 times probably. That sounds right. 5 times 4 is 20. Carry your 2. You get 120. So you get 0 there. You would fill in one more 0 for that. So you also get 350 for this. So you got to pull back. I mean, calculus makes you go all the way back to, yeah. We might want to work on that. They put some of this, they expect you to have like a base level here. They expect you to be able to do that. And you do have to do that here because you have to be able to know it's 350. Unless you can just look at that, 840 over 2.4, and be like, oh yeah, 350. So you do have to know how to do that to know that it's 350. So limit from the left and limit from the right are 350. N of 8 is also 350. You don't really have to do work for that because it's just plugging it into that bottom equation because that's where your or equal to is. It's also 350. So yes, N of t is continuous at t equals 8 because the limit as x approaches t of 8 of N of t equals N of 8. I probably would have done like another therefore limit as x approaches 8 of N of t equals 350. Like I would have done like a limit conclusion there and then do N of 8 and say that those two are equal. But they did not, and this is AP stuff that they put out there, so it appears like that is like an optional step. If this in fact is good here. Okay, everybody all right on that part? Okay, and then and so make sure you do more than just the limits. But if you only do the limits, you still got 2 points on that. So it's not the worst. And then if we go up here, this is an intermediate value theorem problem. So you must first say n is continuous from 0 to 6. Liam said n is continuous for all real numbers. And that is true because you're continuous at 8. Well, is it true? Oh, it might not be true. No, that would be a negative value. Like the denominator of this, 2 plus 0.05 t equaling 0, that's going to be a negative 0.05. T equals negative 2. Yeah, you're going to get negative for that. So that doesn't have a discontinuity anywhere. So it is true that this is continuous at all real numbers, so it's okay to say that. It might be safer just to say it's continuous on the interval they gave you in case it wasn't, in case you messed up part B. So it might be safer just to say that it's continuous from 0 to 6. N of 0 is 80. N of 6 is 300. So you would plug those two in and get those values. They wrote it as one big thing. We have not been doing that just because it gets a little confusing looking. We did N of 0 equals 80, and we found N of 6 and said it was 300, and then we did N of 0 less than 250, less than N of 6, so you could do it that way also. And then you make your conclusion by intermediate value theorem, there must be at least one time t for 0 to 6 such that N of t equals 350 for that. All right, questions? Your assignment tonight is going to be to do that last progress check. Okay, part C, yes. Do you have a question? Let me look back up here because I just took their word for it. Oh, it is stated right here. That's a good question. It is right here. They tell you what it is. Good question. And they love to do that. They love to hide stuff in that stem of the problem that you need somewhere, and they don't put it where you need it. They hide it right there, and you got to go find it.
So F0 is the same as N of 0.
Yes, because N of t equals F of t at 0.
So N is that.
Yeah, so N is F from 0 to 6 anyway.
Yeah. Okay.
Yeah.
It gets confusing when they get to me a lot.
Yeah, they go a little crazy sometimes for that. So if you